cancel. YZ and ZY. These two get cancelled. Okay, so all terms have been cancelled. That means the exponents, the sum of all the exponents is 0. That means it's a to the power 0, right? Which is 1. So as we have this in the third option, so this option should be correct. This is fine for everyone. This was just a very simple question on exponents. You just have to multiply and add the exponents. That's all. Can we move to the next question?
Yes,
If this
ma'am.
one's sorry, what? Can we move to the next question if this question is clear? The second
Yes,
one.
Yes, ma'am.
Okay. This is the second question. Okay. Give this question a try and then we'll do it now. Take 1 minute and do this.
Ma'am, C and D.
Okay, so let's try this one here. You've been given two functions, this and this, and you've been asked the inverses of these two functions. And when you're given two functions, you assume the domain to be the natural domain, right? So the natural domain of this thing is minus infinity to infinity. And for this one you'll have to check, but for this one it's definitely minus infinity to infinity. So you have to keep in mind that the domain you have to take is the natural domain of these two. So e to the for the first option, e to the power x square is one of the functions, and we know for a function to have an inverse on its domain. So if you're taking natural domain minus infinity to infinity, that's the domain we're taking, right? So on its natural domain, it should be 1, 1. But this function is not 1, 1. For this to have an inverse, it should be 1, 1. This is not 1, 1 because it's like x square is not 1, 1, right? X square is not a 1, 1 function. So for minus 1 and 1, x square gives the same value. X square at x equals to 1 and x square at x equals to minus 1 both gives you 1. That means e to the power x square at x equals to 1 and e to the power x square at x equals to minus 1 is same. That means this function is not 1, 1, right? This function on its natural domain is not 1, 1, although it's 1 here. On this domain, it's 1, 1. That's why I've already mentioned that we have to take the natural domain of the function, which is minus infinity to infinity, on which this function is not 1, 1, hence it's not invertible. That means the inverse of this function does not exist on its natural domain. That means you don't even have to check for the inverse. This has to be the incorrect option. The next one, you have square root of e to the power x square minus 8x minus 1. And you have to find the domain of this. So for the domain of this function, first thing is it's a composition of some functions, but let's not do it the composition way. You have to find the domain of each of these functions. If you have f g, if it's a composition of f g and h, you find the domain of each of this and then take the intersection of all of these, right? One by one. So starting from here, you have a square root here. First thing is you need e to the power x square minus 8x minus 1 to be greater than 0, right? So this thing should be greater than 0. For you to find the values of x which will lie in the domain, you need this entire thing, the argument of your square root, to be greater than 0. This implies that your e to the power x square minus 8x should be greater than 1, which is now either you can take natural log on both sides or you can just raise it to the power 0. It's the same thing. So it will be e to the power 0. And then we know that e is a 1 function. If e to the power x is 1. That means if you have e to the power x equals to e to the power y, then your x and y should be same. So from here, if your e to the power, and the same goes for greater than. So even if you have, instead of equals to, if you have greater than, then the same goes here. So if this is greater than e to the power 0, then x square minus 8x should be greater than 0. Now this means your x, if I factorize this, should be greater than 0. And for these two, either both of these factors should be greater than 0. So it's this thing, x and x minus 8, both should be greater than 0 or both should be less than 0, right? So this will give you x greater than 0 and x greater than 8. And this will give you x less than 0 and x less than 8. So I have an OR here. OR means intersection, and means, sorry, OR means union, and your and means intersection, right? So this thing will give you x greater than 8. And this thing, these are two different cases. This thing will give you x less than 0, right? So this is 8 to infinity and minus infinity to 0. And you can include these two because we want this thing to be greater than equals to 0. We missed this thing here. For the square root part, if you have square root of x, you want x to be greater than equals to 0, right? So here it should be greater than equals to 0, greater than equals to 1. So it should be this thing. This one should be included and this one should be included too. So this is the,
Ma'am, can you
this should,
explain the second part, the concept part of it again? Not particularly the calculation, how you arrived, but the concept part. How did you, like,
okay.
from the beginning?
About the, oh, this is your function. We know that when we discuss about domains, we see where your x and the values of x can create problem, right? So if you have e to the power fx or anything, or if you just had e to the power x square minus 8x, then it's no problem because the domain of e, you can include anything, right? So you can raise anything to the power e. That's not a problem. But the problem comes here. In the square root part, we have a problem because under a square root, you can't put negative numbers, right? So to avoid this problem, we want this thing to be greater than 0. So we take this thing to be greater than 0. If you do it the very formal way, you would need it to be written as composition of two functions. But I don't want to go there. Let's do it this way only. So this is your function and you want this thing to be greater than 0. Greater than or equals to 0. Because under the square root, you want things, if this is your function, then you want x to be greater than equals to 0. Right? Because negative values are not allowed under the square root.
Yes, ma'am. After that?
After that, you take this thing and take one on the other side. So one is on this side. Now from here, you can do two things. Either you write 1 equals to e to the power 0, And we know that E is a 1, 1 function, right? So whenever you have a 1, 1 function, this goes for all 1, 1 functions. F is 1, 1. This implies that if your fx is greater than fy, and because it's increasing too, I forgot to mention this thing. If you have this thing, because we're taking increasing greater than, we should also mention and increasing. The e to the power x is also an increasing function, right? Because it's an increasing function and it's a 1, 1 function too. That's why when your e to the power x is greater than e to the power y, your x should be greater than y, right?
Yes, ma'am.
So that means your x square minus 8x should be greater than equals to 0. From there you come here to this point, and then you just solve these things. X and x minus 8, you factorize this polynomial, and then you test where this entire thing is greater than 0. So if you have two factors, either both of your factors are greater than 0 or both of your factors are less than 0, right? These are two cases. For this thing to be greater than 0, either both the factors are greater than 0 or both are less than 0, and then you solve for this, that's it. You want x and x minus 8 both to be greater than 0. That's what we've done here. X greater than equal to 0 and x greater than equal
Yes,
to 8.
ma'am. That's the calculation part is okay, ma'am. Thank you.
Okay. And then for the third part, in the third part, we've asked to find the asymptote or natural log of x square plus 5x minus 24. And it's asked if this is a vertical asymptote or not. So for a vertical, let's recall what a vertical asymptote is. So if let's say this is x equals to 3. X equals to 3 is a vertical line. We say that this is a vertical asymptote if for the function, when your x tends to 3, then this thing goes to infinity or this thing goes to minus infinity. If this happens, then you say that it's a vertical asymptote. So let's check for this function, natural log function, for x equals to 3. So if you have natural log of x, let's consider natural log of x first. If you have natural log of x, then the vertical asymptote is x equals to 0, right? The graph looks like this. And this x equals to 0 line, this is x equals to 0 line. This is a vertical asymptote for natural log of x, right? Or you can say when your x tends to 0, your natural log of x tends to infinity, minus infinity, sorry. The same we do here. So if our x tends to 3, and if this implies that your natural log of x square plus 5x minus 24 tends to minus infinity, it can only tend to minus infinity because we have a natural log function here, right? Or tends to plus, let's have plus minus infinity. If it tends to one of these, plus infinity or minus infinity, then we say that this is a vertical asymptote for this function, right? So let's check. And for that, we only need to check if your x equals to 3 is a 0 of this function or not, right? Because if you have natural log of fx, then this tends to infinity as x tends to something if this thing tends to 0. Natural log of fx tends to infinity when your fx tends to 0, right? So as your x tends to 3, you have to check if your fx tends to 0 or not. So your fx is x square plus 5x minus 24. For that, you just have to check if this x equals to 3 is a root of this or not. So let's just put 3 here. You'll have 9 plus 15 minus 24, which gives you 0. That means x equals to 3 is a 0 of this function, this polynomial. That means when your x tends to 0, this thing tends to 0. Now it's like this. Your x tends to 3. That means this polynomial that you have, let's call it px, this tends to 0. That means your natural log of this polynomial tends to minus infinity, right? That means x equals to 3 is a vertical asymptote for this function, natural log of px. That means this option is correct.
So that covers both the path of x, like the asymptote goes to like infinity and minus infinity, both of them.
No, it covers only, it just has to go to 1. If I've written plus, the plus minus here means, by plus minus, I mean either plus infinity or minus infinity. If it goes to one of these two, then I say that x equals to 3 is a vertical asymptote of this. That's how you define vertical asymptotes, right? If your x tends to a, and then your fx tends to infinity or minus infinity, then you say that x is a vertical asymptote of fx, right? So we are checking this thing, if this is true or not. We check this. That's what we're checking here. This entire thing. Is that okay? Can we move on to the next option? The last one.
Yes, ma'am.
Okay, the last one
Ma'am.
is very simple. It's we've discussed this point a lot of times. For a function to be differentiable, it has to be continuous, right? So, and this option says that if your f may be continuous at a point, even if f is not differentiable at x equals to. So this should be true, right?
Yes, ma'am.
Let me just write this here. If there is any confusion in this one. If your function is differentiable, that means it has to be continuous. But the other way around is not true. The converse is not. It can be true for some functions, but it's not a general rule for all functions. And the contrapositive part is for this is if not continuous, then not differentiable.
Madam, any example of function which is, let's say, continuous but not differentiable?
Continuous,
Mod x.
yeah. Yeah, mod x is one such example where your function is continuous, but it's not differentiable at 0.
Okay, but other point it is differentiable, right? Only at x equal to 0, it's not differentiable.
Yeah. Mod x is not differentiable at 0 and it's differentiable everywhere else. In general, a continuous function might not be differentiable, but a differentiable function is always continuous. And this is just another way of saying it. Not continuous implies not differentiable. That means this option should be correct. You can have a function which is continuous at a, but it's not differentiable at a point a. Okay. Can we move on to the next question if this one's clear?
Yes, ma'am.
Okay.
Yes, ma'am.
This one's the next question. Give this one a try.
Ma'am, FOG will be the third option.
Can we do this here if you guys are done doing it? Done trying this one. Okay. So, been given two functions, and then there are questions on the composition of these two functions. So your FOG should be first. You find the domain, you need FOG first. So FOG of x should be f you take, and then in f you just replace the x with gx, right? So it will be square root of x square minus 1 plus 5 and square root of x square minus 1 minus 3. So this should be the composition. And then we check what's the domain of this. So your third option is correct, that means. And for the domain part, first thing is, now the things that can create problem in this one are the square, first three are the square roots, this one. This is a problematic factor. So we want this, so we want x square minus 1, the argument of square root function, to be greater than equal to 0. The first condition is this. And then the second one you get from the denominator, you want the denominator to be non-zero. That means you want x square minus 1 minus 3 to be non-zero. These are the two conditions, right? So when you solve this, you have x minus 1 and x plus 1. And if you simply solve it, because we've done it a lot of times. So if your x square is greater than equals to 1, that means either your x is greater than 1 or your x is less than minus 1. And this gives you minus infinity to minus 1 and 1 to infinity, right? From first condition, you get this thing, and then you take the intersection of these two, right? So, and from here you'll get your x square minus 1 minus 3 should not be 0. That means x square minus 1 should not be 9, right? And then x square should not be 10. That means your x should not be plus minus 10, square root of 10.
Ma'am,
Yes,
ma'am, there was a x greater than 1, it means 1 to infinity.
yeah, so we've written 1 to infinity here.
But
This
it is
one is
before the
this.
OR function, no?
It doesn't matter. It's the union. Either you write this one first or this one first. It's the same
Ma'am, it
thing.
should be a close bracket at 1.
It is closed at 1. Both of these are closed.
Okay, ma'am.
So this will, from the second condition, you will get this. R minus root 10 and minus root 10, right? And from both of these, because you take the intersection of both of these, so you should get minus infinity to minus 1. When you take the intersection of both of these, what that means is you have this one. You just remove root 10 from here, root 10 and minus root 10, right? Right? Because you want both the conditions to be true. So from this condition, you get this thing. But we see root 10 and minus root 10 are still in this domain, right? We want these two things to be out of the domain from this condition. That means you need to remove, I should be using this number, root 10 and minus root 10 from both of these. So it should be minus infinity to minus 10. Then you're excluding minus, if you leave it at this, that's also fine. Do we have this in options? We don't have, we have written it in different manner. So let's write it in that manner. Minus 10, not included. That's why we've used open bracket here. Then union minus 10 to minus 1 included.
Madam,
Then
it should be
union,
root 10 or minus 10.
yeah, sorry.
Root 10, root 10.
It's 1 to 10. And then 10 to infinity. This should be the answer. Let's see if that's the given answer. Yeah. This one should be correct. And then the second one says R minus root 10. This is not correct. They have not taken the other part, this part into consideration. They have not considered this part. That's why this is incorrect. And then let's come to the last one. about GOF.
Ma'am, ma'am,
Yes. Yes.
ma'am, in second option, real number minus other than minus root 10 and plus root 10, ma'am.
What? What? Sorry.
Ma'am, in second option, the domain is except minus root 10 and plus root 10, na?
Yeah.
In first option, we consider we excluded minus root 10 and plus root 10. Why they both are not same?
These two.
Ah, yes, ma'am.
Okay. In these two. One is, okay, let's just graphically see why these two options are not same. This is your real line, and then you have 0. Let's say you have root 10 here and minus root 10 here. So here you have everything on this real line except these points. So you just have removed these 2 points and everything else is considered in this option. But in the other one, you have minus infinity to 10. Let's say you have minus infinity here, and then you have minus root 10. So you have considered till this part. And then, okay, can you see in this part? Let's just do it in a simpler manner because this, okay. In this option, the second one, in this one, you don't have minus 1 to 1, right? This one. This part is not in the domain. Or whatever's written here, minus 1 to 1 is not a part of this thing, right? But in the
Yes,
second
ma'am.
one, minus 1 to 1 is a part of this thing, right?
Okay, ma'am.
So
Thank you.
these two are different. Okay.
Got it.
Coming to GOF. GOF, you just put this thing here. So, and X is, instead of X, you write this thing. Square of this thing and then minus 1, right? Yeah. So when you solve this, you have X plus 5 squared minus X minus 3 squared by X minus 3 squared. And this is, there's a formula for this. So A square minus B square is A minus B and A plus B, right? So this should be X plus 5 minus X. So you'll get this cancel and you'll have
16x plus 16.
15 here. And from the other one, you'll have
16.
16.
Yeah, ma'am. 25
Okay, you'll
minus
have
9,
8.
16.
8 here. 8 here, and from here you'll have 2x plus 2, right? Yeah, so this thing will be 16x plus 16. And in the denominator, square root of this thing. And then in the denominator, you have, when you have x square and square root of x square, you write it as mod x. Not write it as it is mod x. Because when you put minus 3 here, minus 3 square, so it becomes 9 and square root of 9. So you get 3 here, right? So that means if you put a negative number here in this function, you should be getting the negative of that number. So if you're putting minus 3, the answer that you're getting is minus of minus 3. It works like mod function, right? But when you put a 3 here, 3 square root, you'll get 3. So when you put a positive number, you get the same number. When you put a negative number, you get the negative of that number. That means a positive number. So it should be mod x. So here also, if you have this thing, x minus 3 squared and then square root of it, it should be mod of x minus 3. What's the option?
Ma'am, but
This is it, right? Yeah, what?
Ma'am, you said the under root of x minus 3 whole square can be written as mod of x minus 3. You're saying that?
Yeah.
Yeah. Okay, ma'am. Okay.
We have the explanation here for that. Okay, so this should be the composition, and in the option it's the same, right? This is correct. Can we move to the next question if this one's clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. This is the next question. Give this one a try.
Option D. Option B.
Let's do this one here. First option is that the sequence is not converted. Let's just see what the sequence is first. You've been given A not equals to A naught is not there. We have A1. A1 is 0, A2 is 1, and then you have A3, which is the sum of the previous two and then divided by 2. So it will be half. Then you have A4, the sum of previous two and then divided by 2. So it will be 3 by 4. And then A5, the sum of these two and then divided by 2. So it will be 8, 5 by 8. And for A6, we have,
Can you repeat this once?
okay, we're just adding the last two terms and then dividing by 2. So if you add these two, divide by 2, you'll have 1 by 2. If you add these two and divide by 2, so it's 1 by 2, you can write as 2 by 4, 3 by 4, so it's 5 by 4, and then you divide this whole thing by 2. So it gives you 5 by 8. Do the similar thing here. So it is 6 by 8, 5 by 8. You take the sum, it's 11 by 8, and then you divide by 2, so you'll have 11 by 16. Okay, this is your sequence. And we can't keep finding things like this. So we'll have to have a general term for this, an sort of thing, where we can write everything in terms of n, right? So let's just have a look at denominator first. The denominator is, here you have 2 to the power 0. Denominator is 1 here. So here you have 2 to the power 0. Then in the second one, you have 2 to the power 1 and 2 to the power 2. So this one's simple, right? So it's 2 to the power n in the denominator. The denominator term is,
Ma'am, I think it's just 2.
Ma'am, it should be 0. 0 is equal, A is 0 is equals to 1.
we're talking about the denominator of these terms. We're trying to find the relation in the denominator, a sequence of denominators. So the denominator sequence in this sequence is 2 to the power n minus 1 actually, because this is, yeah, if you'll consider this, forget this one, and if you'll consider this thing from the second one, then you'll have 2 minus 1. So in the denominator, here you have 1. So it's 2 to the power 0 for the second term. For the third term, it's,
n minus 2.
yeah, so it should
2
be
power n minus 2.
power n minus 2. For n greater than equals to 2. Just 1 second. Okay, let's do one thing here. Let's start the terms from here itself so that the things become easier from here. So we're starting the sequence with 1. If it's a convergent sequence, either if even if it's 0, 1, then 1 by 2, 1 by 3, this thing goes to the same thing. And if you start the sequence from here, 1/2, remove this one, this also goes to the same point, right? So I'm taking this sequence. 3 by 4, then 5 by 8. So for the denominator, you'll have 2 to the power n minus 1. This is your denominator
Ma'am, how do you
sequence.
take that sequence? Like
Which one?
these two sequence, like how did you took it?
1 sec.
Like
Go.
after the pause, what did you told? Just didn't got that. After the pause that you took.
If this is a sequence and it goes somewhere, let's say this converges to A. We don't know what this A is. If this entire sequence goes to A, or if you say A1, A2, A3, and so on, this goes to A, then A2, A3, if you just remove one term, or even some terms, if you start this sequence from A10, you will have A10, A11, A12, and then you have this, let me call this one B1, right? Let me make a new sequence from here. I'm calling this to be the first term of that sequence. Then second is this one, third is this one. Then isn't this sequence also going to the same point A?
Yes,
The
ma'am.
subsequence of this one. This is the
So
subsequence of this. And they're going to the same point, right? So we're considering this to be the sequence. We're removing 0 because 0 is repeat. The problem is 0 is repeating here. 2 to the power 0 is repeating on both 0 and 1. That's the problem.
Ma'am, but how are you taking the denominators 2 to the power n minus 1? Because there is one 1 by 3 also in the sequence.
No, 1 by 3 is not there. It's my mistake.
1 by 3 is not in the
Four.
sequence.
Oh, it's not there.
by 2, 3 by 4.
This is the sequence.
Yes, ma'am.
So this is the denominator. And then for the numerator part, we have, so we look at the numerator, it's 1, 3, 5, and 11, right? So here, this pattern's not very noticeable. It's 2 to the powers, and then it's basically you just add these two. If you have this thing, then yeah. So this is one pattern is the, but here we're making the use of the last term. It's doubling this thing and then adding 1 to it, and then doubling this thing and subtracting 1. So it's going multiplying with 2 and then subtracting 1 to get this, and then multiplying with 2 and then adding 1. Sorry, here
Ma'am,
you add 1.
how did we obtain the numerator?
It's from here.
Ma'am, show the
1,
question.
3, 5, 11 from here. We have 1 repeated 2 times, and it's just even better if you start taking terms from half itself, because one is the numerator is repeated 2 times here. So for you to have a pattern, if we use n here, we won't have this pattern. So let's just have it from half. Denominator still remains the same. This is the numerator. And then into 2 plus 1 again.
Ma'am,
This,
please
but it
show
makes
the question.
what?
Please show the question.
Here's the question.
Okay, ma'am.
You just have this sequence. That's the question. And you have to find where it converges. This is the sequence. But we're still writing it in recursive manner only. It's not going to help. Recursive in the sense that we're making use of the last two terms. Last terms. So we're making use of the previous term to, in this one, to find the next term, you're making use of this term, right? If you do it this way, take the double of this and subtract 1. Take the double of this and then add 1. Take the double of this, that's the next numerator. Take the double of this and then subtract 1. So it should be 21. Then take the double of this and add 1. So it will be 42 and 43. That's numerator is working, but if we'll take it this way, we're using the recursive pattern. We want to get rid of the recursivity. Recursivity in the sense that we don't want the previous term to have any role to play in the next term. So for the numerator, it's, if you will take 2, we'll have 3 here, right? And then if you will take 2 square minus of square, let's take a square here. So you will have 4 and minus 1, so which is 3. Again, and then if you have 2 cube minus of minus 1 cube, so you'll have 8 and then plus 1, so it's 9. And then you'll divide this thing by 3.
Ma'am, can't we do it directly from the question, like without like solving the series?
How do you directly do it from the question? It's, if you don't write it in a general form, if you don't write the term in the general form, how do you solve it then? Because it's a
Ma'am,
recursive sequence. Yeah.
because it's given that like if you see the question, an is equal to an minus 1 and an minus 2, right?
Yeah, it's an minus 1, an minus 2
Yeah.
divided by 2, and then you take the summation.
And n is greater than or equal to 3, right? So if we take n as 3, so we'll get our
Okay.
first term.
Get a2 and
Plus
a1.
a1. Yeah. And we have been given value of a2 and a1. Right? And similarly, if we take a4, right? So we will get a3 plus a2 by 2.
Okay.
Yeah. So we will get a like general pattern from this.
Yeah, that's how the
We are
sequence
only,
already we taken.
we've already
That's
taken it
already
here.
done.
That's the first thing we did here. Now we're trying to find a general term for this, because from this sequence you can't actually figure out where it's converging.
Ma'am, for denominator, you have written two general form, 2, uh, 2 raised to power n minus 1 and n minus 2. Which one is correct?
Where this one, we're taking this one because we're taking the sequence to be this. Half 3 by
Okay.
4 and then 5 by 8, we're taking it to be this. Actually, we're considering the other part too, 0, 1. But yeah, we're considering this entire thing, but we're taking the denominator to be this. Consider the sequence to be this. Then this denominator works. This one. And then for the numerator, we have this thing. Let's just try this pattern. We're trying this. So if you'll put a 1 here,
Ma'am, is this a series of like odd numbers? 1, 3, 5, 7, 11, or is it?
the 7's not here. It's how is this a series of odd numbers? 7's missing,
Okay.
9's missing, a lot of odd
Okay.
numbers. So this is it. Let's just check this one by one. If you have 2 to the power, so this is 2 to the power 1 minus of minus 1, 1. We got 3 here, right? 3, or what did we get? We'll get 1. And if you do 2 square minus of minus 1
Ma'am,
square,
I think you have to take plus in the middle. Then you'll get it correct.
this one's also fine. No, we are getting,
The bracket is -1, so when it comes out, it will become plus. It
Actually,
becomes 3.
minus will
yeah,
become
okay.
plus.
So
Okay,
it's
this
2.
is 3 then.
The middle should be plus. Then you'll get it correct.
Let's
2 to
test
the
the
power
minus first
n
and
plus.
then
Yeah.
do the plus one. Let's see which one works. 2 to the power 1, this will give you 3, and then if you have 2 square minus of 1, so again we're getting a 3 here. Right? Minus 1 cube, so you'll get plus, and this is 9, you'll get a 9 here. If you divide these numbers by 3, you get 1, 1, and 3. And what's the next one? 2 to the power 4 minus 1, 4. So it's 16 minus 1, so it's 16, right? 16. Divide by 3, so you get 5. And we have here this one. So you'll have 1, 1, 3, 5. Right? We're getting this when we divide this thing by 2. It works fine, right? Yeah.
When divided, it's by 3, ma'am, not 2.
Yeah. Dividing by 3. We're dividing this thing by 3. And we're keeping the 1 here because we get 1 2 times. and then 3, 5, and so on. I think the other one should work too. You have this thing, it's
Ma'am,
this one's 32, and then, yeah,
the statement 2 and 4 will be correct, right?
statement 2 and 4.
Option 2 and 4.
Yeah, second one and fourth one are correct.
Ma'am, why we are dividing it by 3?
Because we see a pattern here, and it says if you just divide by, firstly, every number is divisible by 3, and then
Okay, ma'am.
if
Okay,
you
okay.
look here, it's 1, 1, 3, and it's, if you just divide by 3, you'll get the same sequence. Here you'll get 33. Divide by 3, you'll get 11. So it's 1, 1, 3, 5, 11, and you have the same thing here, 1, 1, 3, 5, 11. So that means
I
this
have a
works.
confusion in denominator general form. Can you repeat that one?
Yeah, we'll come to that one. This one's clear, right? For n greater than equals to 1. This works for n greater than equals to 1. And this one, if you will take, we have started from here. So this is, we have a 1 here, 2 here, and 4, 8, right? So it's 2 to the power something, n form. That's clear, right? So if you do for n, if you put a 1 here, you'll get 0. 2 to the power 0 is 1. If you put a 2 here, you'll get 2, 2 minus 1, which is 1. So you'll get the 2 here. It's following the pattern, right? Do it for n greater than equals to, but then, okay, do it for this one. Now is it fine? Then also there'll be a problem because now the terms have changed. We have 2 to the power 0 2 times, 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. So we should take 2 to the power, this is the first term, this is second one, this is third one. It should be 2n minus 2 then. For n greater than equals to 2. Okay, let's just,
Ma'am, but for n greater than or equal to 2, the first and
one
second term
second.
has to be 1, na?
Greater than equals to 2, what? Let's remove this one. Now it's fine, right? This sequence, this works. 2n minus 1 works for this sequence, right? For the first term, if you put 1 here, you'll get 2 to the power 0. For the second one, if you put 2 here, you'll get 2 to the power 1. So it's 2 here. So this denominator works for this sequence, right? And let's just let's just remove this one from here. But then you will have to make the changes to n. Right now we have 2 to the power n here. If we'll remove this thing, we'll have to make changes to n here. Let's not remove this here. Let's not remove from here either. Let's take 2n minus 2. This gives you 2n minus of minus 1 to the power n. Where you'll have 1 by 3, 2n minus 2. From here, you will get 4 by 3. Now, if this option is correct, then it should be 2 by 3, not 4 by 3. The numerator we've started from 1. We've considered all from here, right? 1 half and then 3 by 4 and all. 1, 2, yeah, we have it from here only. Our sequence is 0, 1. So we've removed the 0 in both the numerator and denominator cases. We've flipped the 0 part from both of these. Remove this term from both. So it should be 2n minus 1 only. Now if you'll put n equals to 1 here, you'll get 0. So for the first term, the denominator should be 1, which is true. For the second term, you will do 2 minus 1, so it's 2 to the power 1. For the second term, the denominator should be 2, which is 2. So this should be the denominator, right? So here you should have 2n minus 1. Should I repeat the denominator part one more time, or is it fine? The
Yes, ma'am, one
denominator
more
or the
time.
numerator? Okay.
Yes, ma'am, one more time.
So what we're doing here is we're removing this part of the sequence. This part, that means but instead of taking 0, 1, half, 3 by 4 and so on, we're just taking this sequence because this sequence also converts to the same point, right? So we're removing 0 from here and considering just this sequence. So when you have this sequence, now if you look at the denominator sequence, it's 2 to the power 0 here, then 2 to the power 1. So this is your first denominator, this is second denominator, this is third one, and then you have 2 cube and so on, right? So for the first term, you should have, this is your first term. So we can't take 2 to the power n because 2 to the power n will give you 2 to the power 1 here, right? So you should take 2 to the power n minus 1 here. The denominator is 2 to the power n minus 1, and then this is actually a little trying to observe the pattern what's going on. So it's, we've taken 2 to the powers and then subtracted and added 1 each time. So for adding and subtracting alternatively, we're doing minus 1 to the power 1. So when there's an odd power, this thing will get added. When there's an even power, this thing will get subtracted. That's why we're alternating this. To alternate the sign of minus 1, we're doing the powers of minus 1. And then
Can't we
here,
just put 2 raised to power n for denominator and start n is equal to from n is equal to 0?
what? You can, but
Can't-
then you're saying that why are we just flipping this one, right? Why can't we just keep this here? Is that your question?
No, madam, he's saying why can't we use 2 to the power n only instead of n minus 1?
Because
Instead
we've
of n
taken
minus
this
1.
one. This is the sequence of, if you will take 2 to the power n in the denominator, your series is this one series, not series, sequence. This is your sequence. What is it? I'm just writing the denominator, right?
So
I'm
for
not
the
bothering about
denominator
any
and
numbers.
numerator, for both general equation, the मतलब n 1 से इक्वल और बड़ा रहना चाहिए दोनों टर्म्स के लिए.
What? For the denominator part, the denominator part's actually very easy. It's for the first term, you have 2 to the power 0. So the powers are, you can't take 2 to the power n in the denominator because for the first term, you have 2 to the power 0. Then for the second term, you have 2 to the power 1. That means if you do 2 to the power n, you'll have 2 to the power 1 here. But we have 2 to the power 0 instead. That means you should be subtracting 1 from here, subtracting 1 from here, subtracting 1 from here to get what you want. Right? This is the actual sequence in denominator. So if you take just 2 to the power n, you will get 2 to the power 1 here instead of 2 to the power 0. If that was your question.
Ma'am, how
Yes.
would we know that we have to like subtract -1, a minus of -1, -1 whole square minus 1 whole cube in general to get what you got the values? How should we even consider that this option would be there to solve it?
It's just you just have to observe the pattern. I mean, this is because if you'll consider this thing, it's just 4, and then here you'll have, if you consider it this way, you'll have 2, then 4, then 8, then 16. I don't know. I've just tested this one, and there's no rule for it. It's just sit and try and think where you just test things and you just try to observe the pattern. That's all.
Madam, is it not a
There's
good
no hard
idea
and
to
fast rule
test
for
from the options given?
what would you test from the options? They're just directly giving you the limit. They've not given you the
I mean, option 3 and 4, if we try.
3 and 4. You have to check. They might not be correct. These two options can be incorrect, right? You can't use these two options to find the sequence.
Okay.
All in all, you just have to test
No,
things.
what did
That's
you
all.
say last about the option? We have to check it. Why? What was your sentence?
Someone suggested that why don't we just make use of these two options to find the sequence? So to find the sequence in general form, you can't use these two because you don't know if they are correct or not, right? These two might be incorrect options. Then if you use these two to find the sequence, then your sequence will also be incorrect. That's why I don't use this information, at least not in this question, to find the sequence. I thought it from here only, from the 3-1. So if you could just do these things, and then it didn't go as per what I thought, and then just dividing by 3 made the things easier. I was expecting it to turn out to be something like this only from 3, 5, and then but I didn't get any of it.
Okay, ma'am. Thank you.
So after getting the general form, how to know which options are correct?
Once you have the general form, then you're done with the question. It's just then you just find the limit. That's all. Limit n tending to infinity. For this, you have, if you take this thing, we have 1 by 3. Here you'll have 2 to the power n by 2 to the power n minus 1, which is just 2, right? If you, we can just write this entire thing to be just 2. Minus 1 to the power n, 2n minus 1. This is the same as this, right? N tending to infinity. And then, because only this part involves n, so it's this 2n minus 1 and n tends to infinity. So this is the alternating part which just affects the sign. So one time you will have 1 by 2, then 1 by 4, then 1 by 8, so on, so on. So only the signs will be altered. I don't know if this is the correct alternation between signs, but only these things are going to change. So if you have this thing A1, A2, A3, and so on, and without sign, if this thing goes to 0, and if this sequence goes to 0, and I decided to alternate the signs here, that from this sequence, I'll make another sequence A1 minus A2, A3 minus A3, and so on, so on. Where do you think the sequence should go? This one. First, we had this sequence. This was going to 0. And now we're alternating the signs in this sequence to make another sequence. This is sequence 1, this is sequence 2. So where should the sequence 2 go then?
Zero only.
It'll go to 0 only because the signs, when something's going to 0, the signs don't matter then. Only when it's going to 0. Otherwise, things will change. Because this sequence half, 1 by 4, 1 by 8, this entire sequence goes to 0. Right? Half, 1 by 4,
So
1
ma'am,
by 8.
you are saying either the sign doesn't matter in the sequence -1/2 +1/4 -1/8. It will
Yeah.
all the
When
way
the
it will go to
sequence
0.
is going to 0, if you have a sequence AN and this goes to 0, and now you decided that I'll change this sequence, I'll make another sequence out of this sequence, and I'll change some of the signs from here, or all the signs from here. It doesn't matter, the sequence will still go to 0. So changing the signs only when the sequence is going to 0 is when this does not matter. When it's going to some other point, then it's going to matter. If this sequence was going to say 1, then this sequence might not go to 1. This sequence might not even converge then.
Ma'am, same goes for infinity and minus infinity.
If your sequence going to infinity, if you say this sequence A1, A2 is going to infinity, that what does that mean is it's continuously increasing, right? This sequence is increasing. It never stops increasing. Now, if you will put minus sign somewhere, that means it's not increasing. Then how is it going to? If you have see, if you will just change some signs, you say A1 to AN, and then this sequence goes to infinity. If you will change only some signs, let's say if you're changing till A30 or A40 or A100, a finite number of you're getting my point. If you're just changing till some term of the sequence, if you're changing the signs, then it's fine. Eventually, the signs should be the same. Like after a point, if your signs are same, then it's fine. But if you're continuously changing the signs everywhere, A1 you're changing, then A3 you're changing, then A6 you're changing, then A9 if you're changing it all multiples of 3 or all multiples of 9, that means you're never stop. You're not stopping to change the signs, right? You're continuously changing the signs. That means this will not go to infinity now. In fact, it won't even converge then. Because some part of it will go to, for simple example, would be minus A1, A2, minus A3. If you alternate the signs here, then this A2, A4 part will go to infinity. And minus A1, minus A3, minus A5 part will go to minus infinity, right?
Okay, ma'am.
This thing is going to 0. Because this thing is going to 0, that's why changing signs is not going to matter here. 0 is important here. So this sequence is also going to 0 then. That means this entire thing goes to 0 and you're only left with 2 by 3. That means your limit is 2 by 3.
How did that 2n become 2? Can you explain?
What? This one?
The general form.
What do you have a doubt? Do you have a doubt in this one? The form itself? What's the doubt? Does anyone have a doubt in this till
No,
this
ma'am.
part? Whatever
No,
we've
ma'am. It's
discussed so
fine.
far?
We can move forward.
Okay.
Ma'am, I have a question.
Yes.
So suppose this question come in an exam, right? And I somehow solved the option 4. So like, is there by any chance like I can use option 4 to get option 2?
If you're somehow able to solve option 4 and it comes out to be correct, you're saying that if this option turns out to be correct, then yes, you can use to find it the sequence.
Okay.
First, make sure that your
Ma'am, we can get
this
option
is true.
4 very easily. Actually, I was not able to get option number 2.
Yeah, the option 4 is easy. You can use it to find the sequence.
Okay.
If you're not able to find it by hidden file method, you can use the info that you have to find the sequence. And your fourth option, second one's not correct. You can just test the second one, the third one. the third one's incorrect, you can just put some value here and test for it. So let's do it for, so you're starting from 3, let's do it for 4, n equals to 4. So A3 and, what's the sum of A3 and A4? The sum is this, right? The sum is 5 by 4. You have 5 by 4, and on the other side you have A2 plus A2 plus AN minus 1 from 3 to n minus 2. N minus 2, you can't use that here because n minus, if you take n equals to 4, you will end up with 2. You can't take from 3 to 2. Let's take n equals
Ma'am,
to
we are
5.
trying for n is equal to 4.
We're just trying, this option is incorrect. So we're just trying to find if we can just find an example and put values there and see why it's incorrect. Whether, so either you directly do it, put things here, or you solve it a bit and then test it. Solve it a bit in the sense you have A3 to AN, right? On the LHS you have this, and then on the right hand side you have A2 by 2, AN minus 1 by 2, and A3 to AN minus 2, right? So here you will have AN minus 2, AN minus 1, and AN. All of this will get cancelled here, and then you will be left with AN
Ma'am, how
minus
are
1.
you doing this one? Just if you can throw some light. How are you doing this? Like,
We're just
any example?
expanding this thing. So you have AI, I varying from 3 to n. That means A3 plus A4 plus A5 till AN, right? This one. This only, right? A3 plus A4 plus so on till AN. And then for this part, it's A2 by 2, this one, A2 by 2, AN minus 1 by 2, and this sum there, then from A3 to A3 to AN minus 2. This one. And then this part, this sum and this sum, because it's the same, so they get cancelled, and you're left with AN minus 1 plus AN, A2 by 2, and AN minus 1 by 2. Right, so if you subtract this thing, you'll get AN minus 1 by 2 plus AN is equals to A2 by 2. So you can just get this thing from here. That means if this option is correct, if your third option is correct, then this statement is the equivalent of third option. This should be correct too. Your A2 is 1, right? A2 is given to be 1. So you can just directly put 1 here. And then you just have to check if this is true or not. So if for any AN minus 1, check for these values. Let's test from here. So you have 3 by 4. Let's take 3 by 4. And the next one, 2 times of the next one, you'll have 5 by 4. This is 8 by 4, which gives you 2, which is not equals to 1. That means this option is incorrect. Is that okay? This
Ma'am,
entire thing for option C. Yes.
Madam, we can also use n equal to, let's say, 4 directly in the option 3, right? Like, no.
Yeah, you can use it directly here.
Yeah,
ma'am,
But
why
for
did you
some,
equate it?
yeah, what?
Ma'am, why did you equate it? AN minus 1 plus AN is equal to A2 plus AN minus 1 upon 2?
Because we're solving this. They've also equated it, right? Now we don't know if this is equal to or not. That's what we have to check. But for this, we're just putting equal to here, and then we'll check if these two are equal or not. So this statement is equivalent to this one, right? If this one is true, that means your option third is also true. Equivalent to C. So if this statement holds for every n, that means your option C is correct. but this is not true for every term in general in the sequence. So that means your option C is incorrect. Sometimes what happens is you might test some terms, and from there you might get these things equal. It doesn't mean that it's equal. If you get this expression to be true for some terms, for n equals to 4, 5, 6, that doesn't mean that it's true in general. For that, you need to prove it that this is true. Is that okay?
So, ma'am, first you subtracted it and then you equate it in a way.
So I just
Which
simplified this one. I have just simplified the third option, and the simplified form gives me this. This form is the simplified form of your third option. And then I'm just checking, putting values from this sequence. The sequence is 0, 1, half, 3 by 4, 5 by 8, 11 by 16, and so on, so on. So we're taking any two consecutive random terms and testing them here, if it's true for them or not. So we put these two here, consecutive terms, and we see that it's not equal to 1. That means the statement is not correct. This is just a simplified version of this, the third
ma'am, how
option.
do you open the sigma, the n-2 sigma till I is 3 ai? What about that? How to open that?
1 second. We have sigma from I varying to from 3 to n minus 2. This is one of the summation, right? That means you start from, this is ai, you start your I from 3, so it will be a3. Then, and you go till an minus 2, right? So it's a3,
Yes,
a4,
ma'am.
a5, so on, and before n minus 2. So this will be it. And for this one, I varying from 3 to n, let's say you will have a3, a4, so on till an. But when you will have an here, that means an minus 1 is also here, right? Just right before this one. And an minus 2 is also here, right before this one. Is that okay? Okay, then coming to the fourth one. The fourth option is summation from 3 to n and summation from 3 to n minus 2. And an minus 1 by 2. So you simplify this thing again. This is the same as a3 to an, and on the other side you have a3 to an minus 2, right? So here you have an minus 2, an minus 1, and an. And on the other side you have this to an minus 2 plus an minus 1 by 2. This will mean now this thing to n minus 2, this entire thing and this entire thing, they get cancelled because they're on both sides. So you will be left with an minus 1 plus an is equals to an minus 1 by 2. This summation starts from 2. So you will have a2, then a3. So you'll also be left with a3 on this side, right? a2, sorry. a2, an minus 1, an, and then this thing. This thing will give you a2 plus an minus 1 by 2 plus an equals 0. We written this thing correct, 3 to n, then 2 to n minus 2. and an minus 1 by 2. This will be a2, a3.
A2
This
is
side
on the
we have
right hand
3
side.
to n. Here it was here. So we'll have a2 here. So your a2 is on the right. This will give you an minus 1 by 2 plus an equals a2 is 1, right? This is 1. And then you just have to use this, the formula, the recursive formula given to you. So that an is an minus 1 plus an minus 2 by 2, right? And then you add this thing, an minus 1 by 2 equals 1. So from here you'll get an minus 1 by 2 times is an minus 1 plus an minus 2 by 2 equals 1. Now
Ma'am,
doing
how
through this
this
part is enough to,
ma'am,
yeah,
how this it equals to 1?
because your a2 is 1. We had a2 on the a2 is 1. Value of
And
a2 is 1.
an minus 1 upon 2 is?
An minus 1 upon 2 is a
Okay.
random term. So first you add this thing an. Let me just write it. An plus an minus 1 by 2 equals 1. Now you have an minus 1 and an minus 2 by 2. That means the term plus the previous term divided by 2 equals 1. Okay? That's what the pattern says. That means you should have. And what does the option say? So you need to check if this is true or not. For this, you'll end up with a2 plus a1 by 2 equals 1. That means, and your a1 is 0, right? And a2 is 1. So this is 1. This is 0. That means this is true. This is true. The previous one, that means this is also true. Then all the others are also true. Is this fine? So from the option given to you, when you solve it, simplify it, you get this. An minus 1 by 2 plus an equals 1. You have to test if this is true or not. Right? So to test this thing, we use the recursive formula and get an minus 2 by 2 plus an minus 1. And if you do it further, you'll get an minus 3 by 2 plus an minus 2 is equal to 1. And if you keep going on like this, you'll end up with a2 plus a1 by 2 equals 1. Now, if this is true, then this is also true, this is also true, this is also true, right? And we test that this is true. That's why all of the previous ones should be true. That means your fourth option should be correct.
Ma'am, the last thing, when you were solving it, there on the last one,
Yeah.
you got it 1. Here, just before that, an minus 1 upon 2 plus an is equal to 1. How did you culminate into 1, like the formula?
Which this formula,
Yeah,
it's here only. It's
yeah,
okay. You're clear till
just
this part, right?
yeah, just before
Yeah,
this
just
part.
replace it.
Yeah.
This part is just a simplification of what's written. They've just opened the this summation sign, and we end up
Yeah,
with
how
this
did
thing.
you how did you simplify it? That's all.
रिकॉर्डिंग में मिल जाएगा भाई.
It's you just open the summation sign. That's all. I've written it here.
Yes, ma'am.
Just try to check this thing. You'll understand. It's just you're just opening this summation sign. That's all. 3 to n and 2 to n minus 2. A2 to n minus 2. Can we move to the next question now?
Ma'am, just one
Yes,
last
ma'am.
question.
Next question.
Yeah.
Ma'am, so if we know like the last option is correct, so like just one idea, like how can we like predict that the second one is also true? Like how can we know the limit of the thing?
The third's true, that means you have this thing true, right? This one's
The fourth option.
yeah, the fourth one. That means you have this thing true. An minus 1 by 2 plus an is 1, right?
Correct, yeah.
That's what I was saying. When you use the general term, this is again a recursive formula. By recursive, I mean you're using for the next term. If you use an from here, you will be using the previous term to find an, right?
Okay.
But we already have a recursive formula. So we want an in terms of just n. Just n like we had there, 1 by 3, and then something in terms of the an that we found here. Where is it?
Yeah,
It's purely in terms of n. We're not using any other terms here. We're not using an minus 1, an minus 2. But in this case, you're using the previous terms.
Okay, got it.
Ma'am, in this question on the right hand side, just on the right hand side, when you were solving the third question, third option here.
Just 1 second. One thing you can do here is, because you know that you have an minus 1 by 2 plus an equals 1, and we know that the limit of these two is same, right? Now you can use this thing as limit n tending to infinity. The limit of an minus 1, if this is a sequence, limit of this thing and limit of an sequence is the same, right? Let's just call these two as a. So this limit is a by 2 plus a equals 1. So you'll have 3 by you will have 3 by 2 from here, right? 3 by 2 a. A should be 2 by 3. Now from here you can find the limit. That works. Is that okay?
Okay, got it. Thank
So
you.
you can actually use this thing to find the limit. Or actually, you could use that recursive formula too. We have this recursive formula, right? an minus 1, an minus 2 by 2 equals a. So if you do it here, you will have a. Use limit on both sides, limit on this and limit on this. You will have a equals to, but from here you're getting the same thing, a by 2 plus a by 2. So you can't find a. So from here you can't find a, but from here you can.
Okay, got it. Actually, I
Ma'am,
was
the last.
if n tends to infinity, then an also tends to infinity. That's why. Okay.
Ma'am, this formula, how did you came on that? An, the limit one, the last step that you told.
Okay, this part that you have, the fourth option is correct, right? Fourth option is correct, and from fourth option we came to this. This is just the simplification of fourth option, right? That means this fact is true. So you can make use of this fact to find the limit of an. What you do is you put limit on both sides of this equal to sign. So you will have limit of an minus 1 by 2 and an, and take the limit here, limit n tending to infinity. So limit of 1 is 1 only. This limit is 1 only. Now limit of an minus 1, if an minus 1 is a sequence, an is a sequence, then the limit of both of this is a only. If this goes to a, this also goes to a. Okay? So if your an goes to a, that means your an minus 1 also goes to a. So from here you will have the limit of this thing is a by 2.
Ma'am, how
limit
it goes
of this
to a?
thing is a.
An minus 1 goes to a? How?
They're the same sequence. So we discussed this thing. If you have
Okay,
a1, a2, a3, and if you remove something from here and you start from here, then this sequence also goes to the same thing which this sequence was going to, right? Is this okay?
Yes,
Yes,
ma'am.
ma'am. Okay.
Okay, can we move on to the next question?
Yes, ma'am.
Okay, the next one is this. So you have been given the stock price in terms of Y represents the stock price, and then X represents the number of months, right? They've given the example. January is considered 10, so November should be considered 10. No, January is considered 0. So January is considered 1, November is the 11th month. So November should be 10th then, because the January is 0, right? So the January is allotted the number 0, then November should be 10. Now if the stock price of the company goes to 0 in November, so that means f, your y is f, right? F of x is minus 7 log base 2 x plus a plus 35. So they say that in November, your F10 is 0. In November, this becomes 0, right? The stock price goes to 0. That means your F10 is 0. That means minus 7 log base 2. Now, if you will put x equals to 10, you will have 10 plus a plus 35. And this thing is 0. And you have to find the value of a. So from here, you will have log base 2, 10 plus a equals minus plus 5. And then raise both of these to the power 2. So you'll have 10 plus a equals 2 to the power 5, which is 32. So an a should be 22. That's all. Is this okay?
Yes, ma'am.
This is the next question. You guys want to give this question a try, or can we just directly do it here, because we're left with very little time? Let's do it here only then. So Ravi has borrowed 3,000.
Please explain the previous question again.
This question is, this is your y is the stock price and x is the number of months. But the first month, where x equals to 0 implies January, right? And when your x is, that means when it's November, because if they're talking about November, so x should be 10 there, right? If January is assigned the number 0, then November should be 10.
Yes, ma'am.
And this is the function. So the function gives you the stock price, and this x is the number of months, right? This x is this 0, 1, 2, 3, 10.
Yes.
So they're asking you the value of a, and they're saying that the stock price in November, that means when your x is equals to 10, the stock price f of 10 is equal to 0. So you've just used this information, put x equals to 10, y equals to 0, and find the value of a. That's we've just solved this equation.
Stock price is 0 in November.
Yeah, it's given here. No? The stock price of the company goes to 0 in November. Is that okay?
Okay, ma'am. Then why it is plus 5 log 2 10 plus a equal to plus 5?
We've just solved this equation. That's it. Just solve this equation.
Okay.
You'll get this thing. Okay. Coming to the next one. Ravi has borrowed 3,000 and 12,000 from two different friends. And then this friend is the rate of interest here is 7%, and for 4 years. And from here it's 10%, and for lend the money 10% for X years. You have to find the value of X, and this says the compound interest. So this is simple interest here. This is compound interest here, as per the question. So the compound interest is thrice the simple interest. So first you find the simple interest using this. Then you find the compound interest using this. Use this equation, find the value of X. You simply, we need to do this question here. Can you guys give this a try? Because it's a very simple question. Just
We can give it a
given the
try,
formula
ma'am.
too. Very
Ma'am,
simple. You have been given the formula. Both the formulas are simple interest and compound.
Is the
Yes.
answer 2?
Yes, the
Yes,
answer
yes,
is 2.
answer is 2.
Yes, ma'am, we got it.
Okay. Can we come to this one then? The 7th, 8th, 9th ones. So I've been given a function here, and you have to find the value. So first you have to find the value of p. Given the function, the limit of the function x equals to 0 exists. So for limit, what you do is, as x tends to 0 minus, you'll use this function, right? Which involves p. So it will be p e to the power x minus 4x plus 3. And the limit will be, so it's 0 here, p plus 3. So the left hand limit will be this at 0. And for the right hand limit,
sin x.
yeah, use this one. So it will be r sin x plus 9 cos x. So if you use x tending to 0 plus, this will be 0 and this will be 1. So you'll have 9 from here. That means your p plus 3, for limit to exist at 0, this is your right hand limit. Your p plus 3 should be equal to 9. That means your p should be equal to 6. Then coming to the next part, your function is given to be continuous at 0. So for continuity, your limit
Ma'am,
was 9, right?
the last part, can you explain the right hand limit part? We put 0 in that. So we got 9,
Yeah,
9.
because your x sin
Okay.
x when x tends to 0 is 0, cos x when x tends to 0 is 1.
Okay, ma'am.
Okay. So next up, you have the function as continuous. So for continuity, you will have q minus 5 equals to the left hand limit and right hand limit at 0, right? The left hand limit and right hand limit was 9. We have it here, 9. That means your q should be equal to 14. And then for r, you have been given differentiability. So for differentiability, because we know that this function is continuous at 0, so we can just directly use the derivative of the left hand branch and the right hand branch. The left hand branch will give you, because it's q minus 5, sorry, this one. The left hand will give you p e to the power x only minus 4. And p is 6, right? So p is 6, you'll have this for the right, left hand derivatives at x equals to 0. And actually, you should substitute 0 here. So you'll get 6 minus 4, 2. This will be 2. And then for the right hand derivatives at x equals to 0, you can just use the derivative of this. So r cos x, you will have r cos x minus 9 sin x. And if you put 0 here, you will have r, right? So your r should be 2. Is this fine?
Ma'am, how LSD become 2?
Your left hand derivative for at 0, what you do is, if your function is given to be continuous at 0, you can directly use the derivative of this, right? The derivative of this thing is p e to the power x minus 4. But your p is given to be 6, so you put 6 here. You'll get 6 e to the power x minus 4. And you have to find the derivative at 0, right? So you put x equals to 0 here. So this is 6 minus 4, 2. Is that okay?
Madam, how about the second part? Like eighth question, if f is continuous at x equal to 0, then how
If
we
you have
make it?
If your f is continuous, that means your left hand limit, this is left hand limit at 0, right? So left hand limit at 0 and right hand limit at 0 should be equal to f0, right? So your f0 is q minus 5 and your right hand limit at 0 is 9.
Okay.
Ma'am, can you just zoom in? I want to take a screenshot of this. Yes, ma'am. Thank you.
Can you just explain the part of q by 2, eighth question? Why did we like take 9?
And if it's q by 2, because we've just found the value of q. So you should be doing, for q by 2, you should be having 7.
7, yeah. Okay. So 9 is because the limit over there, the right hand limit is
Right
9
hand
or
limit is 9. Yes, it's the
okay.
right hand limit. The right hand limit at 0 is 9.
Okay. 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 Thank you.
Okay. Can we move on to the next question if this one's clear? This one is the next one. So you've been given two things here. This and some values. Because you've used the derivative here. So let's take the derivative of this function on both sides. You'll have f dash x plus y, right? And then you take the derivative of x plus y. So you're taking the derivative with respect to x. On both sides, you take the derivative with respect to x. D by dx on this and d by dx on this side. Fx and f. So if you take the derivative here, you'll have f dash x plus y using the composition rule. And then you take the derivative of x plus y with respect to x, right? So the derivative of x plus y with respect to x is just 1, right? And here you'll have derivative of fx and fy because this is entirely a function of, that means it's constant with respect to x, right? If this is just a function of y, that means it's a constant function if we consider it with respect to x. That means you can take this thing outside as y. This will be f dash of x plus y. This is just 1 equals fy and f dash x. That means this. Is this clear to everyone? Then you just have to use this information.
Yes, ma'am.
Okay. The first question is f0. You have to find f0. So you can do this thing here. Because you have been given f1, so you can make use of it. Take x equals to 1, y equals to 0. You have f0 and f1, right? Actually 1 here and 0 here. Doesn't matter, but still. This is what you're going to have. And then f1 equals f1 and f0. Now if your f1 is not 0, which is true, right? Your f1 is 5. You can just directly write 5 here. 5 and f0. 5 gets cancelled on both sides. That means your f0 is 1. So the value of f0 is 1. And then for f dash 1, you use this one. For f dash 1, you put 1 because you want f dash 1. So in place of x, you should be putting 1, right? So f dash 1, put 0 here because you know the value at 0. And do f dash 1 plus 0 here. So you will have f dash 1 equals what is f dash 1? Have we f dash 1 we have to find, right?
Ma'am, we can take
X as 0, madam, because f prime 0 is
f
given
dash
as 3. X becomes 0.
Can we use, would we get a different answer from here? That's what I'm trying to test.
Yeah, madam, f prime 0 is given as 3 in the question.
Yeah, that's given, but I'm trying to use this one and see if we are going to get a different answer. If we
Take
will
f
come to this
dash of 1
approach.
plus 0 is equal to f of 1 and f dash of 0. You'll get it that way.
But we should be getting this, we'll come to this approach later and see if we get different answers or not. So we'll have f dash 1 here, f1 and f dash 0. I think we have the values of both f1 and f dash 0. So it's 3. And f1
Into
is
5.
5. But if we'll do it this way, you'll have f dash 1, f0 and f dash 1. So this would mean,
F dash 1 will
okay,
get
we
cancelled.
don't get,
F of 0 is 1.
okay,
Yeah.
we can't actually use this one.
Ma'am, the last approach, like the last step, how did you do that?
Which one?
Yeah, this
You
one.
have,
Like just before that, can you explain the above of it, like 5 is equal to 5 plus 0, just above on the right hand side?
this one.
F, yeah, ma'am. Just before that, explain.
This one you don't even have to differentiate. You have been given fx plus y.
Yes, ma'am.
So we've just put x equals to 1. In this expression, put x equals to 1, y equals to 0. So you get this thing. Now we know the value. We have to find the value of f0. F and the value of f1 we already know. We're making use of that here.
So F1 is given in the question, na, ma'am?
Yeah, it's given in the question. We've used it here.
Yes, ma'am. And ma'am, just
Even
below,
if,
just below it,
yeah.
just below it, this approach. How did you do that?
First you come to this expression because we know that we're trying to find the value of the derivative at 1 or derivative at 0. We're trying to find the value of derivative at 1. So we first find, right, we have been given the expression in terms of just f, right? So we try to write it in terms of f dash first. And this is the expression that we get.
Yes,
And
ma'am.
if you're done with this expression, then you just put the values and we're looking for f dash 1. Right? We're looking for f dash 1. So either you put x equals to 1, y equals to 0, or y equals to 1, x equals to 0, and see what happens there. The way you'll get f dash 1 here. And if you put x equals to 1, you will have f dash 1, and both of these will get cancelled. There's no point doing that. Let's not do that part.
Ma'am, but
Let's
why
put
1,
y
0
equals
and
to
0,
1.
1? Ma'am, why we are taking x is equal to 1 and y is equal to 0
Because
and
we
y is equal
want
to
to
0?
find, if you will do something else, if you will take x and y to be something else, then you will have f dash a here, right? But we don't know where a is x plus y. But we don't know what that f dash a is, right? And we're looking for the value of f dash 1 only, right? This is what you have to find. If you have to find f dash 1, then this is what you should be putting, right?
But why taking y is equal to 0?
First thing that comes to mind is that you can directly put 1 here, right? This one just looks easier. So you consider putting x equals to 1. But if you put x equals to 1, then you'll have to put y equals to 0. Otherwise, you'll have 1 plus something whose value you don't have at f dash. So to avoid this thing, you'll have to put y equals to 0. But if you put y equals to 0, you'll have f dash 1 and f1. Now these two will get cancelled and you won't get the value of f dash 1.
Okay, ma'am.
Right.
And when you were solving it, f dash x plus y d by dx just above two lines x plus y. So the dx plus y by dx that will become 1, na, ma'am, because the dx by x
Yeah,
that
that
is
is
1.
1. This part is
Okay,
1.
okay. And y is a constant we have taken, so it's 0. So 1
Yeah.
plus 0 in a way. Okay.
Y is a constant. That's why we have taken this. Yeah, that's why the derivative of y is also 1. Sorry, 0. Derivative of y
And,
is 0 and derivative of x
and
is 1.
derivative of x is 1 here.
Yeah.
Okay. So 1 plus 0 is.
Can we move to the next question? This is the last one, I guess. Yeah. This is the last question. You have been given a sequence, and the first question is about the terms itself. So if you have n by 2, floor function. Floor functions, what it does is, if you have 1.5 or 2.5, it just goes to the lowest integer, like the closest lower integer than 2.5, right? So it goes to 2. So if you have n by 2, for even this is easy because if your n is even, then it's divisible by 2, right? So you'll have an integer here. This n by 2 thing, if n is even, then n by 2 is an integer. And if your n by 2 is an integer, what's the greatest if you have x here, where your x is an integer, then this value is x only, right? That means if you have n even here, your n by 2 is an integer, and this floor function of your integer is the integer itself. That means it should be n by 2. So if your n is even, floor function of n by 2 should be n by 2 itself. So this option is correct. And this has to be incorrect then, obviously.
Madam, first
Then-
option is correct, no?
Yeah, we'll
First-
come to that because even
Okay.
was doing it for even ones is easier.
Mhm.
That's why I discussed the even part first. Then for odd one, if you have this as odd, then it should be what it does is if you have, let's say you have 3. If you have half, it will be 0. If you have 3 by 2, it will be 1. If you have 5 by 2, it will be 2, right? So what it does is you can't divide directly by 2, but it subtracts 1 and then divides by 2. Same it does here, subtracts 1 and divides by 2. 7 by 2, you're going to get 3. So what it does is subtracts 1 and divides by 2. That means this should be equal to n minus 1 by 2. Is this okay? That means this option should be correct. This should be incorrect. A and D are the correct options. Then coming to this one, 4an, the limit of 4an you have to find. Your an is this. So for odd, because we know n by 2, greatest integer for odd is n minus 1 by 2. So you can replace it with this by 7 plus n. For odd n, and for even n, we have 5n square minus 4n plus 1. Now for the limit, if you will take the limit of this thing, because you have two things here now. So it's like this, A1, A3, A5, and then A2, A4, A6, two sequences, which should be going to the same sequence for you to have the same, for the limit to exist. Right? For the
Ma'am,
the
for
limit of-
even can't in place of n square, we need to substitute n by 2.
No, it's for n even it's this only. Just
Okay.
as we have substituted this thing because here we had n by 2. So
Floor
we know that
function.
yeah, we had floor function here. That's why we replaced it. Here we don't have any floor function. So you just check where this thing is going and where this thing is going. And if these two are equal, then the limit exists. And because you've been asked to find the limit, that means it exists, obviously. So let's try to find it out. 3n. If you solve this, you'll have 6n minus n plus 1 by 2. So from here you will have and 7 plus n, right? So from here you will have 5n plus 1 and 2 times 7 plus n. Divide by n on both numerator and denominator, you will have 5 plus 1 by n times 7 by n plus 1. And if you take n tending to infinity, if you will take the limit of this thing, then limit n tending to infinity will be 5, and here you will have 2. So it should be 5 by 2 from the odd sequences. And from the even, because you can test it, but if you've been asked the limit, it's obviously common sense. If you've been asked to find the limit of a sequence and it's a numeric type question, then obviously the limit exists. But you can test it for the other one too. If you just want to be sure, you can test it for this too. So 5n square minus 4n plus 1 divided by 6n plus 2n square. So just divide the numerator and denominator by n square. So you will have 5 minus 4 by n plus 1 by n square and 6 by n plus 2. So if you take n tending to infinity, for this one, you will have 5. This is 0, this is 0. This is also 0, so this is also 5 by 2. That means your an tends to 5 by 2. So your 4an will tend to 4 times 5 by 2, so it's 10. The limit of this thing is 10. And then for 4an square minus 10an, an tends to 5 by 2, so this should tend to 5 by 2 square 4 times minus 10 5 by 2. So this is this is 0. Both of these are 25 and 25. That means the limit of this thing is 0. We're done with both of these, all the questions now, not just both of these. We're done with all questions. If there are any doubts, you can ask. Else we can end the session here.
Ma'am, there was one.
What?
Ma'am, can you just zoom in this question?
Which part?
Ma'am, there is one question of sequence that you said, that particular sequence question that took a lot of effort from your end. Maybe question 3 was there.
This one.
Yeah, ma'am. Just if you go to that question, just particular to that question. Just I'm using my phone. That's why I said it. Yeah, on the right side, the right part, the C part of that. When you explain it, can you explain this
Yeah.
thing once, like from the question till the end?
The question was, what was the question? Summation 3 to n and then summation 3 to n minus 2. And then on this side, I think we have a2 and an minus 1 by 2. Right? This was the question. So here, you just need to know how to expand this summation. That's all. So you start with 3. So this will be a3 and you end with an, right? You go till an. So this is a3, then a4, then so on till an. And here you go from 3 to an minus 2. And you already have a2 by 2 and an minus 1 by 2. And if you check this thing, this is from 3 to n. This is from 3 to n minus 2. And n minus 2 is obviously smaller than n. That means this comes before n. That means here you will have a term. This thing is the same as a3, a4, so on till an minus 2, an minus 1, and then an, right? These two things are same. We've just written it more properly. And on the other side, we have this thing. So that means from a3 to an minus 2, we have on the left-hand side. These two terms gets cancelled. They're on the both sides. So this and this gets cancelled. You're left with an minus 1 plus an equals a2 plus this thing, right? So you take it to this side, you'll have an minus 1 by 2 plus an equals to a2 by 2. So just multiply both sides by 2 to have a better looking expression. That's all. Otherwise, you've reached the required point. So this will be an minus 1 plus 2 times an equals a2. And we know that a2 is just 1. It's given, right? a1 is 0 and a2 is 1. So that means your final expression is this. So to check if that option is correct or not, you can check if this is true or not. Now our original sequence was 0, 1, then half, then 3 by 4, 5 by 8, and so on, right? So now these are two consecutive terms, an minus 1 and an next to each other. Let's consider this to be an minus 1. Now, if that option, whichever option it is, if that's correct, that means this should be correct for all n belonging to natural numbers, right? So let me just take the n to be, this is a1, a2, a3, a4. So this is a4. So let's take n equals to 5. So you will have a4 plus 2 times a5 equals 1.
Ma'am, the second
Your
step,
a4 is which one?
the second step, an minus 1 upon 2 plus an is equal to a2 by 2. How did we reach there from that step?
This one?
Yeah, how did we reach there?
From here.
Yeah, how?
We're not doing anything. We're just
Yeah,
we just
the cancel part,
expand
I
this
got it.
thing. You're
Yeah.
clear till this part, right?
Yeah.
Then
Yes.
we're just subtracting this. This is an minus 1. This is an minus 1 by 2. We're just
Yeah.
simplifying this. That's all.
S-
Take this to this side. You'll have an minus 1 by 2 plus an.
So an minus 1 minus an minus 1 by 2, that become an minus 1 by 2. Like,
Take this to this side.
yeah. So how did it become an upon 2? an upon 2? an minus 1 by 2.
On the right hand side, you have an. On the left hand side, you have an minus 1 by 2. You bring it to this side, it will be an minus 1 minus an minus 1 by 2. So this is just an minus 1 by 2, right? This one. This thing is equal to an minus 1 by 2, right? And then the rest of the expression we've kept same.
How, ma'am, an minus 1 minus an minus 1 by 2 become that?
Take an minus 1 common from here. It's 1 minus half only. You know, what is this thing? Is that okay?
Yeah.
Ma'am, I have a question. Like the first step, if you can scroll up, like the very first. Yeah, so this one, sigma AI is equal to, how did we get this one? The right hand part. Is that the option 3?
This is one of the options.
Okay.
We're testing one of the options. It's in the options.
Okay. So this sigma AI is like the summation of like the whole series, correct? And it is equal to the correct option 1.
This summation, this is one of the incorrect options. You have to test this one, and at the end, you will see that this option is not true after simplifying. We've done it. We've tried to put values in it, and we've found that the equation is not consistent. These two things, this doesn't come out to be equal to this. This is the final equation that we get after solving. And this is not a series, it's just sum. Series is when you take I varying from 1 to infinity. That's what you call series.
Okay, got
This
it.
is not a
So
series.
this is from I3 to sigma n. So this is called what? N minus 2. This is called what?
This is just the sum.
Okay.
Sum of sequence from 3 to n minus 2. That's all.
Can you just zoom in, ma'am? I just wanted to take the screenshot of this. So on the left hand side, you said you took it an minus 1 minus an minus 1 by 2.
Yes.
And you took n minus 1 as common, so it become an minus 1 by 2. Okay.
Okay.
So
Anything
here you
else?
took n minus 1
Yeah.
common from an minus 1 minus an minus 1 by 2 to you took an minus 1 common.
Yeah.
So, okay.
Ma'am, I've pasted a question in the chat. You can just explain how are you supposed to approach it. That would be helpful.
Yeah, 1 second. Just 1 second.
In this question, ma'am, an minus 1 plus 2an is equal to a2 is equal to 1. So it how it is 1, ma'am?
Which one?
An minus 1 plus 2an is equal to a2 is equal to 1. So from the series, we can
2
say
is
that
equal
a2
to
is
1
1.
is given in the question. It's
A2
given in
is
the
equal to
question.
1. Yeah, yeah.
This
Okay.
is given in the question. Okay. So the question is, you have been given a function fx equals x plus 1, x plus 2 for x greater than equals to 1, and the other part is just less than 0. This function is not defined from 0 to 1, right? Here it's not defined. It's 1 by x minus 5. This is your function. And the options are limit when x tends to minus 2 from the positive side.
That is okay,
X
ma'am.
tends
Just the
to,
continuity.
okay,
That part I need to understand.
continuity and just the second option then.
Yeah, the second and the last option. Or the correct or incorrect.
Okay. And x equals to 1. Let's just put this one. So at x equals to 1, your domain is this, right? Minus infinity to 0, not included, and then from 1 to infinity. But 1, you just have, now, if you have
Right hand.
1 and you don't have anything, you can only approach from the right hand side, right? There's nothing to approach from on the left hand side. So you don't calculate the left hand limit and you just calculate the right hand limit. And that should be equal to the function's value, which is true, right? This function has no problem. X plus 1 and x plus 2 does not have a problem at x equals to 1, right?
Yes.
This is a continuous function at 1. So if you put the value of this, of 1, if you put x equals to 1 here, then it's the same as,
The right hand.
yeah, the right hand limit. Right hand limit at x equals to 1. That means it should be continuous at, so this is
Ma'am,
continuous at x
the
equals
reason
to
for that is because it's not breaking at 1. That is one of the reason. And
yeah, that's one of the reasons, but the main reason here is that there's no left hand limit to be found at 1. So there's no
it's not in the
concept of left
domain.
hand limit. Yeah, the left hand side of 1 is not in the domain. That's why there is no concept of left hand limit at 1. So you don't have to find it. You just have
That
to
means
find the right hand limit.
0.0001 0.000, like that one is not
Yeah,
in the domain.
0.999, you can say this thing
Yeah.
is not in the domain. Yeah, that part's not in the domain. That's why you can't find the left hand limit. We don't say that it doesn't exist. We say that the concept of left hand limit is not valid here.
For the function, then it is continuous at 1.
Yeah, it's continuous at 1.
And if the other one is continuous, like there's no definition on what they want to put continuous. So that we should consider it as domain, continuous on its domain, or option 2.
Yeah, if you have been given a function, then obviously they're asking about the natural domain of the function. So when they say f is continuous, they mean f is continuous on its natural domain. The other part, it doesn't even exist. That's the meaning. So for this should be correct because it's continuous on its domain. And actually 5 is 5 in the domain.
No,
5
it's
is
not,
in the
man.
domain.
It's outside. It's not in the bottom
Yeah,
part. It's
it's
in
in
the
the
upper part.
domain, but it's in this part.
Yes.
So it's continuous then. So no problem in this function. So it should be a continuous.
And if they ask whether it is continuous on R, then it is not because the domain
It doesn't
is
even
different
exist
from
on
R.
R. Yeah.
Yeah. Okay.
Remember, it is continuous at 1. That was the first question.
Yeah, it's continuous at 1, and in general, it's continuous on its entire domain. F is continuous on its domain.
Okay, ma'am.
Anything else?
And for the last part that you said, the last thing that you explained,
What last part?
the last part of that, what was the student that asked 1 upon x minus 5? So
Yeah, we were talking about the 0.5, x equals to 5. So x equals to 5 it would have been a problem if x equals to 5 was a part of this branch. But x is equals to 5 is a part of this branch, so there's no problem.
okay.
So domain of this function will be domain of the first one and the domain of the second one, correct?
Yeah.
Okay.
Ma'am, even at 0, it is not dependent because x is less than 0.
Yeah, that's why we have an open bracket here, not defined at 0. Anything else?
Ma'am, how is it not defined at 0?
Because your question says for x less than 0, the function is this. That means before this part, it's this. And after 1, including 1, it's this.
Okay, got it.
For this part, it's not defined.
And x is equal to 5 is included because it goes on the upper limit,
because
the upper part of that.
Yeah.
Mhm.
Okay. Anything else?
That's it.
Okay, if there are no other doubts, then we can end this session here. Okay. Thank you, guys. Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, madam.
Thank you.